Good morning. Myself, Dr. Maheswara Rao, Department of Civil Engineering, Institute of Aeronautical. So our course name is Fluid Mechanics. Today's topic is stability of floating bodies. So before going to this, so the course outcomes, that means after completion of this, so what the students will able to do or learn. So that is course outcome. One is the students can define the fluid, what is the fluid and what are their properties and what is the surface tension. So all those things will come under the course outcome 1. And course outcome 2 is the classification of fluids based on the Newton's law of viscosity. So that means fluids are classified based on the Newton's law of viscosity. The fluids which obeys the Newton's law of viscosity we will call Newtonian fluids, and fluids which will not obey the Newton's law of viscosity, they are called non-Newtonian fluids. And the problems related to the viscosity. So those come under the course outcome 2. Course outcome 3 is the capillary rise or fall. That means whenever you insert a smaller diameter tube inside a fluid, some fluids will raise the level inside the small diameter tube, so which is called capillary rise. Whereas some other fluids, if you insert a smaller diameter tube in the fluid, those fluids will fall inside the level of the smaller diameter tube, which is called capillary fall. So, the capillary rise or fall is come under the course outcome 3. And course outcome 4 is the surface tension. So, any fluid will have some surface, and that surface will maintain a tension, which is called as surface tension, and their applications will be as course outcome 4. Then course outcome 5. So here compressibility. So compressibility means whenever you apply a external force, so the fluid changes its volume. So that shows the compressibility. Okay, or density changes. Fluid density if changes by the external application of the force, then it is a compressibility. So here compressible fluids, incompressible fluids, 2 types are there. So whenever the fluid changes its volume or its density due to application of external load, those are called compressible fluids. Examples are gases. And whereas some fluids will not change their volume. So neither change the volume nor change the density. So density will be constant, volume is also constant, even with the application of the external force. Those are called incompressible fluids. Example for that is water. That is the course outcome 5. So course outcome 6, the last course outcome is the fluid friction or frictional losses or fluid pressure. So whenever the fluid is flowing inside a pipe, so on the surface, internal surface of the pipe and the fluid will have a contact surface. So there frictional forces will be developed. So due to that, energy will be lost. So if a fluid is flowing from one point to another point, so frictional losses will occur. So that means energy will be lost from point to point. So there will be loss of energy. So those are called fluid friction and pipe flow or fluid pressure. This is under course outcome 6. And today's topic is stability of floating bodies. So here, stability. Stability means what? So if they are in equilibrium. So equilibrium means that is called a stability. And floating bodies. So in a fluid, if the object is floating, for example, ships, boats, etc. So that object is floating, that is called a floating body. Example, ships. So how the stability is there? So there's contents we will deal today. So here you can see here, first line. So if the body does not return to its original position, that means if you apply an external force, small tilt is given for a floating object, so it will again regain its original position. Then it is called a stable one. If it is not getting its original position, that is a unstable equilibrium. neutral equilibrium. That means if force of buoyancy Fb is equal to W. Okay, that means weight of the object. That means the boat, weight of the boat, and buoyancy force. That means the force applied upward direction by the fluid. So if both are same and also they are meeting at the same point. So two conditions are there. If the body does not return to its original position, that means whenever you give a small tilt, the ship, if it is not coming to its original position, then it is called an unstable equilibrium. Okay, and neutral equilibrium means, so if force of buoyancy is equal to weight of the ship, so both the force of the buoyancy, that means upward direction force of the fluid, and the weight of the ship, both are same. Okay, and second condition is that these 2 points are having at the same point. So the point of buoyancy and point of W is at the same point and also equal, then it is called a neutral equilibrium. Here, unstable means if it is given a small tilt to the ship, if it is gained its original position, that is a stable equilibrium. If it is not gaining its original position, that is a unstable equilibrium. So there are 3 stable conditions. One is stable condition, unstable condition, and neutral equilibrium. So 3 equilibriums are there. If it is returning to original position, that is a stable equilibrium. If it is not returning to original position, that is unstable equilibrium. If the force of buoyancy and this W are equal and acting same point, then it is a neutral equilibrium. So stable means W is acting at downside. That means the buoyancy point is above the weight of that object, ship. Then it is a stable. If the buoyancy is below the weight of the center of gravity of the body of ship, so then it is unstable equilibrium. It will never come to a original position. So you can see in these figures. So in the first figure, we can see it is a stable condition. It is because it's stable condition, it gets its original position now. So it is unstable. It again sinks here because of the moment formation, couple formation. So what is the difference here? In this first figure, we are having B wave, B point of buoyancy. So it is acting here. It is just above the weight of the object. That means ship, CG. So that's why both are acting in opposite directions. So that's why it makes the stable condition because of these vertical forces, opposite forces. Here, whereas the unstable condition, buoyancy point is below the weight of the object, so that this weight of the object is downwards and point of buoyancy is upwards. So it is making a couple formation so that it will sink. So the ship is sinking what is coming inside, so that it will sink. So that is an unstable equilibrium. So these are the stability of bodies. So whenever point of buoyancy is upper level than the weight of the object or center of gravity of weight of the object, then it is stable. In the reverse case, it is an unstable one. Then stability of bodies in fluids. So any body in fluids, how the stability is there. So stability refers to a tendency of a body return to its original position. Okay. So if original position is there, then it is called stability. So stability means if it gains its original position after being disturbed. So that means small tilt is given, but it is gaining its original position, which is the stability. Okay. When considering the stability of bodies in fluids, it is important to understand how body behaves when it is displaced from its equilibrium position. So it is very, very important to know the behavior of the body. So how the body behaves whenever it is displaced, whenever it displaces position. So if it is going normally, no problem. If whenever it is small displacement is occurred, then how it behaves. That is the important one here. So here key concepts are there. Center of gravity. So center of gravity, what is the center of gravity? The point at which the entire weight of the body. So if a ship is there, okay. So this ship, center of gravity will act the total weight of the body, entire weight of the body, it may be ship or boat, whatever it may be. That point is called center of gravity. That means total weight of that particular body is acting at a single point. That point is called center of gravity here. For symmetrical objects, with uniform density, CG is geometric center. If a symmetrical object, so if it is just like this is square, so if you cross like this, so this is a geometrical center. And if it is a circular, so it is the center of the circle is geometric center. So CG will be at the same point. But unsymmetrical bodies, then you have to calculate by using the methods. So then after center of gravity, then another important word is the center of buoyancy. So similar to this weight of the body, buoyancy force. Buoyancy force is acting upwards. The fluid is exerted force upward direction. But here center, the total, just like a center of gravity, total weight of the body is acting at some point downwards. Similarly here, center of buoyancy means the total upward force, which point it is acting, the total resultant of all the upward force will act at single point, just like center of gravity. That point is called center of buoyancy. So this one is the center. Of course, upward force will be there on entire body, but there will be some point. So resultant of all these upward forces will act at that point. That is called the center of buoyancy. So here CG is the center of gravity, CB is the center of buoyancy. So we can see it here. What is center of buoyancy? It's the point where the buoyant force or the force due to displaced fluid acts. What is here? Displaced fluids. What is the meaning of displaced fluids means? So if you put an object into a fluid, so some of the fluid displaced by the volume of that object, that immersed volume of the object here. So the centroid of the submerged volume of the body, that is the center of buoyancy. What does it mean? If you take a ship example, say, we will take here. So if water is here, ship will be like this. Okay. So this much portion is submerged in the water, in the fluid. So the volume of this portion of the body displaced. That means water is displaced by the volume of this submerged body. Okay, not the entire volume of the object. So whatever the volume occupied or volume inside the fluid of the object. So it is nothing but the volume of the object which is inside the water. So that is for that one single point will be there. That means total upward pressure will act through that point. That means displaced volume of body. So that is nothing but the centroid of the submerged volume of the body. Submerged volume of the body. So it is not considered because ship can be like this also. Since some fluctuations are there, so then ship can be like this. Now the submerged volume is this much. Okay, here it is because of the tilting. So the center of buoyancy will be changing because it is nothing but the centroid of the volume of the submerged body. Then a stable equilibrium. So a body is in stable equilibrium. So when we will call it stable equilibrium? When displaced slightly returns to its original position. So whenever a displacement occurred, slight displacement, if it is gaining its original position, that is a stable equilibrium. So the condition is that the CB should be above the CG. What is the CB here? CB means center of buoyancy, where CG is the center of gravity. So CB should be at top position and CG should be at bottom position. Okay. So because the weight is here acting, the CB is upward direction. Okay. Buoyancy force. So that is the stable condition. The center of buoyancy should be always above than the center of gravity point. And restoring moment torque generated by the buoyant force acting at CB, the weight acting at CB tends to bring back its original position. How this will keep the stable? Because see here, if it is G, if B is here, center of buoyancy, so buoyancy is acting upwards, gravity is acting downwards. So then what will happen? So it will act, coupling is formed. so that it will never gain its original position. That is unstable. So in the other case, G is acting here and B is above that. So B is acting upwards. So even with small tilt is given, then B point will come here. So then it acts upwards, it acts towards downwards, so that the ship or body will take its original position. So these are the conditions of a stable equilibrium. So there are two conditions. What is that? Center of buoyancy should be above the center of gravity of the body, so that couple is formed, so it will get its original position. Neutral equilibrium. So neutral equilibrium means what? Previously we discussed this is the center of gravity and this is the center of buoyancy. Center of buoyancy acting upwards, center of gravity is downwards, so it is stable. Whereas if center of buoyancy is here, center of gravity is here, so this acting center of gravity downwards and center of buoyancy upwards, so it is unstable because couple is formed, so the ship will sink. In other case, neutral equilibrium is that nothing but, in both the conditions, center of gravity, that means weight of the object, and center of buoyancy, the forces are same. So in both the conditions, stable condition, both the forces are same. Center of gravity force, center of buoyancy force. Unstable condition also, center of gravity force and center of buoyancy force both are equal. And neutral equilibrium also, both are equal. But when it will be called as neutral equilibrium means, here the point of center of buoyancy and point of center of gravity are at different places. But in this, in stable also different places, unstable also different places. Whereas neutral equilibrium, the single point will be there, where the center of buoyancy is acting, also center of gravity is acting. So that means something is acting upwards, something is acting downwards. So, but in the same point. So both the forces are equal and both the acting points are same. So then that is called a neutral equilibrium. Here, see the sentence now. Say a body is in neutral equilibrium when displaced here. When displaced, it stays in a new position without returning or moving further from its original position. So if you give a small tilt here, okay, if ship is here, you have given small tilt, then what will happen? The ship will be like that only. So there is no moving or no without returning. It will not return its original position. It will not sink also. Okay. So because the same point is there, both the vertical, equal and opposite direction forces are acting. So even if you give a small tilt or small displacement, it will not get its original position, nor it will sink. So that is the neutral equilibrium. So this happens when CG and CP coincides vertically, meaning there is no restoring moment. So here, restoring moment will not occur, just like a stable equilibrium. Okay. So different points, whenever you give a small tilt, it restores. Whenever it is unstable, it sinks. So whenever, no restoring moment. So that means neither getting the original position nor sinks. So because of the equal and opposite direction forces are acting at the same point. So even when small displacement, the ship will be in a small displacement only. It will never gain its original position. So stability of floating bodies, metacenter is there and metacentric height is there. So what is the metacenter? What is metacentric height? You can see here. The point at which the buoyant force acts when the body is tilted. Okay. So point of buoyancy is there. That means the resultant of the upward force will act at a certain point. Then what is a metacenter means? If a ship, okay, if ship is there, so then whenever you give a small displacement, so the ship will rotates, swings or oscillates about that point. So oscillates like this. So at a single point, axis point, then that point is called a metacenter. So whatever may be the tilt, the point will not change. Okay, whenever ship is given small tilt, so it oscillates like this based on the some point. So that point is called metacenter. And metacentric height, it is nothing but the GM. So what is the M here? Metacenter. Metacenter means what? It is a point at which the body is oscillating. whenever you give a small tilt or displacement. Height G. G is the center of gravity. So here, metacentric height G is a measure of the stability. So why should we learn this metacentric means? It is nothing but the measurement of the stability. How strong it is stable, how it is not stable based on the metacentric height. So that can be known by means of this metacentric height. So if the body is having more stable, then metacentric height you can see. If it is very less stable, then also you can see the reference to the metacentric height only we can know. So it is a measure of this stability of floating object or body. It is defined as the distance between the center of gravity and metacenter. So it is nothing but the distance between the CG and M. That means center of gravity of the object, total ship, center of gravity total ship, and metacenter. Metacenter means through which the ship is oscillating whenever there is small floating. See here. So if it is G, center of gravity, it is a metacenter M. The distance from here to here, that is called a metacentric height. So it is GM. So GM is equal to BM minus BG. So here BM is the distance of center of buoyancy to the metacenter. So what is the formula given here? Formula is metacentric height. Metacentric height is BM minus BG. So you can see here BM BG. What is the BM here? It is the distance from the center of buoyancy to metacenter. And BG the distance of the center of gravity to the center of buoyancy. So here center of buoyancy is there, center of gravity is here, metacenter is there. So the distance between these two is called BM, and the distance between center of gravity and center of buoyancy is called BG. If you subtract 1 and this BM minus BG, then you will get the metacentric height here. So you can see in this figure. So this is the point of buoyancy B. Okay, this is the G, center of gravity. So the distance between this is center of gravity to center of buoyancy in this figure is BG. So because it is coming from G, B for buoyancy, G for gravity. So BG means the distance between the buoyancy point and center of gravity point. Similarly, BM is the B for buoyancy force, M for metacenter. So BM means the distance between the buoyancy point and the metacentric point. So this BM minus BG you will get. So here you can see the M here. So this M, okay. So this M point, the point at which the object or ship oscillates. So that is called a metacenter. That is M here. Okay. So BM. So from here to here. So this is the BM. So BM minus BG. So then this is called a metacentric height. That means the distance between the metacenter and CG of the body. So here the significance of metacentric height. How will you find whether it is a stable or unstable or equilibrium based on the metacentric height. So metacentric height is nothing but the distance between it is itself a GM. So G for the center of gravity of the body, M for the metacenter. So the metacenter to geometric CG of the body, the distance between them, it is metacentric height. So if it is more than 0, then it is a stable. Okay. So if M is above G, so M is above G, G is here. You can see in this figure. So the G is below the M. So it is a stable one. So if it is 0, then it is a neutral equilibrium. So that means B and G are the same point. So when GM is less than 0, unstable. So less than 0 means if M is less below the G. So that is the unstable condition. Then example, stability of a ship. So how the ship is having stability. So you can see stable ship. So if a ship is given slightly tilted, so a small tilt is given by means of external forces, the metacenter is above the center of gravity. So here center of gravity is here, metacenter is here. The buoyant force creates a righting moment that restores its upright position because Center of gravity is acting up downwards. This is metacentric acting as upwards. So then righting moments. Okay, it is written here righting moment. That means it restores. The ship is restored in upright position so that it is in stable condition. So unstable ship. So when we look at it is unstable ship. If the center of gravity is higher than the metacenter, reverse one. So if center of gravity is top side and metacenter is bottom side, this is metacenter is acting upwards, this is downwards center of gravity. So couple formation, unstable condition. Okay. So if the center of gravity is higher than the metacenter, the ship will tend to capsize when tilted. So whenever tilted, so then it will collapse, the sinks. So that is a unstable one. So factors affecting stability. So on which factors the stability depends. So here you can see this shape of the body and distribution of mass and load and ballast. So these three factors are there. So based on three factors, the stability of the object is dependent. So first one, if you see the shape of the body. Design or shape affects the position of the CB and therefore stability. A wider base generally increases stability. So it is just a shape only. For some shape, you will get more stability. Some shapes are lesser stability. Okay. So then what is here? The wider base generally increases. If the base is wider, then it is having more stable. Okay. So design or shape affects the position of CB. CB means what? Center of buoyancy. The center of buoyancy will change depending upon the shape of the body. So, if the center of buoyancy should be acting top above the center of gravity of the object. So, broader, okay, wider base. So, it will be generally stable one. And distribution of mass. So, vertical position of center of gravity is crucial. Lowering the speed increases stability. So, as you know, center of gravity is always at lower levels compared to buoyancy or whatever it may be. So, if it is at lower level, center of gravity, that weight of the body, or distribution of mass, it should be always at the bottom point compared to buoyancy point, center of buoyancy, metacenter, all those things. So, then that is called a more stable. So, distribution of mass is important here. So, then load and ballast. Ships and boats often adjust ballast extra weight to modify center of gravity and their stability. Here, ships is having ballast. Okay, ships or boats is having one ballast at bottom. Just like you can see, if you take a bulb example for this purpose. So if you take a electrical bulb, so then if you keep small material here, it may be wax or something. Okay, so then if you tilt this in condition, again it gets to original position because of the acting of the center of gravity. So center of gravity will become crucial here. So load and ballast, the ships and the boats are often adjust extra weight to modify the center of gravity and ensure the stability. Thus, the factors affecting our three are there. Shape is there, distribution of mass is there, load and ballast is also there. So the shape is wider base, okay, then it's more stable. The distribution of mass, okay, it should be at lower point, center of gravity, then it is stable. And load and ballast, so if it is extra, it is given to modify the center of gravity so that it will be ensured more stability. So let us review today's. So you can see here, body does not return to its original position. So then it is called a unstable equilibrium. Then neutral equilibrium means the force of buoyancy and weight of the body both are equal, and these both are acting at the same point. So then that is called a neutral equilibrium. You can see in this figure the stability. So here B is acting upwards, G is acting downwards, and B is above the G, center of gravity. Then it is taking righting movement so that it will be in original position. So stable one. If the point of buoyancy is below the center of gravity, weight of the body, it making couple formation. It will sink. Then stability of bodies in fluids. So here stability refers to the body to return its original positions. How quickly the body is getting its original shape, original position. So that is called the stability here. Whenever giving a small disturbance. Okay, it is very important to understand the behavior of the body whenever it is displaced from its equilibrium position here. And the words are here: center of gravity and center of buoyancy. Center of gravity is given for CG, center of buoyancy is CB. Okay, the entire weight of the body is acting at a single point. Body weight, total weight of the body weight is acting at a single point. That point is called center of gravity. Okay. For symmetrical bodies, it is the geometric center is nothing but the center of gravity. For unsymmetrical body, it may be different. Okay, that is the center of gravity. Center of buoyancy is nothing similar to the center of gravity. The total force of buoyancy force, upward force will act at some point. That point is called center of buoyancy here. So it is the center. It is nothing but the centroid of the submerged volume of the body. So that means the volume of water displaced by the submerged portion of the body, that centroid is called center of buoyancy here. It is nothing but CB. Unstable equilibrium, if you want to put the object in a stable condition, two things are there. One is center of gravity will be below the center of buoyancy. That means center of buoyancy will act above the center of gravity, so that it will get stable condition because of the righting moment. So the righting moment will brings back to its original position. That is a stable equilibrium. Neutral equilibrium means both the forces, weight of the body is equal to the force of this upward force, the buoyancy force. So buoyancy force and weight of the both are same and also acting at the same point. So then it is called a neutral equilibrium. If a small tilt is given, it will not restore its moment. So it will be at that position only because it is acting at same point. The upward force, both are same forces acting at the same point. That's why it will not restore. It neither sinks, just like an unstable one. Then it is called neutral equilibrium. Metacenter and metacentric head. Metacenter means whenever a small tilt or displacement is given, the body will oscillate. So like this. So the point by which it is accelerating, that point is called just like a pendulum. If you take a pendulum, so it rotates like this, oscillates. Okay. When a pendulum is this, oscillates at this point. So similarly, the ship also, object also oscillates at a certain point, based on point. That point is called metacenter. So here, metacentric height, it is here GM. GM is the point of the center of gravity. M is the point of oscillating, that is M. So the distance between the center of gravity and the metacenter, it is called a metacentric height. It can also be called GM is equal to BM minus BG. So the metacentric height is nothing but the buoyancy point, that means metacentric point minus buoyancy of that gravity. And that means B to M. B to M and B to G. That means buoyancy to metacenter, the distance, minus buoyancy to center of gravity distance. So both the distance, if you deduct, you will get the metacentric height here. So you can observe in this figure where is the M, where is the G, where is the B. So BM, you can see BM is a longer one. Okay. From this, if you deduct BG, so if you deduct this, then this one is called the metacentric height. So GM is the metacentric height. So it is metacentric is like a reference for the stability of the body, how the body is stable. So metacentric height is more than 0, it is stable, and less than 0, unstable. If it is equal to, that is neutral equilibrium. And ships. So stable of ship. So whenever a ship is given small tilted, okay, so and the metacenter is above the center of gravity, so then it is a stable condition, righting moment and restoring its original position. So unstable ship is the center of gravity is higher than the metacenter. So that means center of gravity is above and this metacenter is below that, then it will sink. It will not gain its original position. It will be unstable. If you see the factors affecting the stability, so there are 3 factors. One is shape of the body, another one is the distribution of the mass, and load and balance. So first one, shape. So if bottom is wider, then it will increase the stability here. Distribution of mass. So if the total distribution of mass is such that the CG will be at lowest point, so then it will have more stability condition. So load and balance. So that means extra weight is given for the ship or boat, so that whenever tilt is given, that mass will change the bring back the center of gravity of that object. So references are K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McGraw Hills 2012, and Modi, PN and SM Seth, Hydraulics and Fluid Mechanics, Handbook House 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.